Every night when we look at the stars, it feels like we're peering into infinity. But what if everything we can see is just a small island in a much greater cosmic ocean? The visible universe, the one captured by our telescopes and satellites, may only be a fraction of a far bigger, stranger reality. The edge of the universe isn't a wall or a border. It's a horizon, a limit to what we can see. And beyond that horizon could lie realms that defy everything we know about physics, time, and existence itself. The observable universe stretches an incredible 93 billion light-years across. Inside it are more than 2 trillion galaxies, each containing billions of stars, planets, and nebulae. It's filled with dark matter and the faint radiation left over from the Big Bang, the cosmic microwave background. Yet, even with the most advanced instruments, we can only see so far. The light from distant galaxies takes billions of years to reach us, and space itself is expanding faster than that light can travel. Beyond that boundary, beyond what we can ever observe, the cosmos continues, invisible, unreachable, and perhaps infinite. This limit is called the cosmic horizon. It exists because the universe has a finite age, about 13.8 billion years, and light travels at a finite speed. Anything farther than about 46 billion light-years away simply hasn't had time to send its light to us. In essence, our universe has an edge not in space, but in time. It marks the distance light has traveled since the beginning of everything. What lies beyond that? That's one of the greatest mysteries in cosmology. For years, scientists believed that what happens beyond the cosmic horizon couldn't possibly affect us. The light can't reach us, and even gravity should be too weak to cross that expanding space. But then came a discovery that changed everything. Something called dark flow. In 2008, astrophysicist Alexander Kashlinsky and his team noticed something strange while analyzing the motion of galaxy clusters using data from NASA's Wilkinson Microwave Anisotropy Probe, WMAP. The galaxies weren't moving randomly. They were drifting together in one direction at astonishing speeds of up to 1,000 kilometers per second. The motion seemed to point toward a region of space between the constellations Centaurus and Hydra. The researchers used a technique known as the kinematic Sunyaev-Zeldovich effect, which measures tiny distortions in the microwave background caused by galaxy clusters moving through it. After months of analysis, the results remained the same: an enormous, coherent drift of matter, a mysterious cosmic current flowing across billions of light-years. It was as if something outside our observable universe was pulling on the galaxies, something massive, unseen, and impossibly far away. If that's true, it changes everything we thought we knew about the universe. One possibility is that there are massive structures beyond our horizon, gigantic accumulations of matter formed before the Big Bang's inflationary phase stretched space apart. During inflation, space expanded faster than the speed of light, pushing once-connected regions beyond each other's reach. If there was a region more massive or denser than ours, its gravity could have imprinted itself on our part of the universe before being flung beyond visibility, leaving behind the strange motion we now call dark flow. This theory hints at a multiverse, a vast cosmic expanse where countless universes exist like bubbles in an infinite foam. Each bubble might have its own physics, constants, and even dimensions. If two bubbles ever collided, it could leave behind a scar in the cosmic microwave background, or gravitational ripples like the ones we may be seeing as dark flow. It's a mind-bending idea. What we perceive as the universe could be nothing more than a small part of a far greater structure, one universe among infinite others. But not everyone agrees that dark flow is real. In 2013, the European Space Agency's Planck satellite conducted a more detailed survey of the cosmic microwave background. The results showed no definitive evidence of dark flow, suggesting that what Kashlinsky's team found might have been a statistical artifact. Still, Kashlinsky stands by his data, arguing that the signal remains, faint but persistent, and that future, more sensitive missions may yet confirm it. If it's true, it would be one of the most important discoveries in human history, direct evidence that our universe isn't alone. Even if dark flow turns out to be an illusion, the question remains: what actually lies beyond the cosmic edge? Some physicists propose a supervoid, an enormous region of nearly empty space so vast that its gravitational effects distort the motion of galaxies near its edge. Others think the opposite, that an unimaginably massive superstructure far beyond our reach could be tugging at the observable cosmos. There's even the radical idea that beyond our visible universe lies a higher dimensional realm, a bulk space, as suggested by string theory, where gravity and matter operate on levels we can't perceive. Whatever the truth, the universe beyond our horizon is expanding away from us faster than light. Those regions will never send their light to us, no matter how long we wait. And the more time passes, the more of today's visible galaxies will slip beyond that cosmic boundary. In a few trillion years, the sky will go dark. The light of distant galaxies will fade, leaving only the faint glow of our own Milky Way surrounded by an endless black void. To future observers, it may appear as if the universe consists of only one galaxy, drifting alone through eternal night. But that's not the end. Just our limited perspective. Beyond the darkness, the universe continues to grow, full of stars, energy, and matter we'll never see. Perhaps entire civilizations exist out there, separated from us by a gulf of expanding space. Maybe there are universes where time flows differently, or where the laws of nature themselves are completely alien. The truth is, we might never know, but the mystery itself is what keeps us looking upward. Every discovery in cosmology has shown us that our place in the universe is smaller than we once thought, but also more extraordinary. The edge of the universe isn't a boundary to fear, it's an invitation to wonder. It reminds us that the cosmos is bigger, stranger, and more alive than we can ever imagine. Every photon of light we capture from the distant past is a message from a time when the universe was young, a whisper from beyond, urging us to keep exploring. The edge of the universe may forever remain hidden, but its existence proves something profound, that the story of creation is far from over. The more we understand, the more questions appear. And maybe that's the beauty of it, that even in a universe so vast and unknowable, we have the power to ask what lies beyond. If you love exploring these cosmic mysteries, hit that like button, subscribe to the channel, and share this video with others who wonder what's really out there. Because in the grand scale of the cosmos, curiosity is the only thing that connects us to infinity.